Hello everyone. Thanks for the introduction. My name is Rodrigo. Oh, hi. Yes, clapping. I came from Dropbox, and I'm gonna talk a little bit about like the general architecture of mobile offline folders and what is it, and kind of like the architectural decisions behind it. So I do have a cold, so like if you at some point you guys cannot hear me, just let me know and I'll raise my voice. So what are we gonna talk about? A little bit of history, like behind the decision of like implementing this feature. They ask, what is offline folders? Like maybe like some people don't know what it is. Kind of like the first implementation, like we tried it, didn't work. Second try, it kind of worked, and like the final implementation. So this is mostly about architecture, like software architecture. So like, if you have any questions, like my #1 passion is software architecture. So feel free to like come and like talk to me about anything related. Credit where credit is due. Like this feature took like a lot of people to implement. A couple of my coworkers there. So like just in case if like they ask you, I actually said that they work on this. Okay, so the evolution, a little bit like history of the Dropbox app. I don't know if like you've ever used Dropbox, but it started like in 2008 as a desktop app. So basically, you install this client, and all of your you select a folder, and all of those folders and files are synced from your laptop to the web, right? And it basically synchronizes everything, right? So like if you have whatever content you have in the web, it will be synchronized locally. Like there's a way to opt out, like if you have like a very big folder and then you don't want to synchronize that. But like basically the idea behind it is that you want everything like that's in the cloud in your laptop. So around 2011, we built the Dropbox Android app, and basically it was like a glorified browser. The only thing that it did is to connect to the web, load the directory, and then just like show the list of files, and obviously preview whatever. And then we added this very basic feature, which was called favoriting. And basically the way it works is that you select a file, and when you select that file, then you make sure that that file stays offline. So if you're gonna catch a flight and then you want to work on that document, then you mark that file as a favorite. So like we make sure that we won't like evict it from our cache. So this is very basic. Of course, you don't want to sync the entire contents of the or the cloud in your device because you would run out of space. So we don't want to do that. So that's a little bit of history. And then so what are offline files and folders? Basically, as I said, the user can mark specific files and folders. So basically, you go and select a file and select available offline. We don't want to keep everything in sync like we do on desktop. The space on mobile devices is very limited. So also like there's network and battery constraints. So you don't want to keep like constantly syncing like files and folders all the time. That's just like a waste of resources. Okay, so what was the ask? I think I've been at Dropbox for like a couple months, and then my boss comes and tells me this. It's like, hey, can you check what's needed to ship offline folders? It was implemented by an intern last year. It's almost finished, don't worry about it. Offline files has been around for some time now. Like it was shipped, I think, like in 2012. That was like 2015. It's like, let me know. So I go ahead and I take a look at the code. And so like, just okay, let's it's like, oh, it doesn't look too bad. It's kind of like the implementation is pretty good, for like an intern. So like maybe there's a couple things that need to be polished, but overall like it looks pretty good. So how do offline files work? So I take a look at the code, and I see like, well, it's very easy, right? Like you basically have a list of files, wherever you want to store that, I don't know. You're gonna like walk through that list and first sync the metadata, which is like file name, size, icon name, path, and hash, right? The metadata of the file. And then you're gonna actually download those assets and sync them. So if the file has been updated, then you need to like download that file again. And we also have preview and thumbnails, which is like scaled down versions. Like if it's an image, we have like scaled down version of that image. If it's a PDF, an Excel file, we actually have like a image of the file, that we retrieve from the server. We don't generate that locally. So look, it's like a very straightforward feature. Like syncing offline files is very easy, not too complex. But now, what happens if you want to do offline folders? Okay, so this is the initial architecture of offline files. Basically, you have like a list and a path, and then you walk down that queue. You store that information in the metadata manager. You store that information in the download manager, and we have a file store, and we have an assets cache. So you might notice that I have a little star there. It says cache. Cache can be evicted, like elements in the cache can be evicted. We don't want that for offline files. So basically, the way we hacked the cache, and basically said like, oh, if the file is an offline file, then do not ever evict it from the cache. So it's kind of like pushing it it's pushing it a little bit, honestly. But basically, it was a hack. So that's this is like what I received. Okay. So I said like, okay, well, if let's try to do this. First things first. Why is implementing offline folders way harder than implementing offline files? Well, there's hierarchies, and then like a single folder can contain 10 more folders, can contain 10 more folders, and so like in general you can have like 10,000 files. And actually that's our limit for how big a folder can be. You cannot offline a folder that contains more than 10,000 files. It's pretty arbitrary, but that's what we came up with. No one has complained so far. Well, some things to think about it. As I said, the first step is to retrieve all of that metadata. But what if you have like a huge folder and only one file changed? Then you don't want to retrieve the metadata for all of those files. So basically, what you do, like what do you do, right? You don't want to do that. Number two, it takes a lot of time to download all of those files. Before, if you had a single file, then I guess you could have like an ISO file with the Linux distribution, whatever, the DVD, right? But in general, it's like small files, like Excel files, pictures, whatever. But now, downloading a huge folder is going to take way more. You're probably going to bet that most of that time is going to happen when the application is not on the background. Like if you download a single file, then it's easy because it's going to take like in a fast network, it's going to take maybe a couple minutes, 1 or 2 minutes. But like 10,000 files is probably going to take like half an hour. So it's there's more constraints. Number three, the user might run out of space on their device. Before, like you could always run out of space on your device, of course. But now it's easier. Like think about it with like a simple action. You can just go ahead and synchronize a folder. It's like 10 gigs, right? So now we exhausted all of the space on your device. So you need to be careful about it. You could always blame the user, but like you need to respect the user and make sure that they don't do like stupid things. Okay. So first implementation. So one thing. First, number one. Delta metadata syncing. So as I said, there's really no need to download the metadata of the entire folder. So maybe we could use deltas, right? Only retrieve what's changed. So this is like very common in many APIs. Basically, you store a cursor, which is like, oh, this is the last time I synced. And please tell me what has changed since the last time I synced. And basically, the server will reply with a list of changes. So instead of downloading everything again, then you will only download the changes. And then this is what's Gandalf. So Gandalf is was our system in Dropbox for experimentation. I guess like Gandalf is like you shall not pass. So like the idea was that it allows you to say like I only want exposed 5 or 10% of the population to this behavior. And if you're gonna change the way you sync files, which is pretty scary, you want to make sure that you do that like in stages. You don't want to change that for like an entire app. And you can also like turn it off in case like something goes wrong. Nothing did, but yeah. Number two is background syncing. I don't know how many people have experience working with like background stuff, like jobs in Android. Okay, it's very hard. And it's getting harder just because there's even like more restrictions in Android N and Android O. So originally we were planning on implementing our own background library. I mean, if you have like 100 Android engineers like to spare, go ahead and do it. But I think like in my experience, it's not worth it. Just use the Evernote. Wait, do I have it here? Yeah, just use the Evernote job library. There's many different ways in different API versions to do background jobs. Just use the Evernote job library. It's pretty cool, and they're very good at updating it. Every time there's a new API. So yeah, they just like updated it. I think like in December for Oreo, which like they even introduced more restrictions for background processing. So just go ahead and do that. And number 3, as I said, protect the user. Right? It's easy to use up all of the space on the device. So what we do is that we make sure that when you offline a folder, you have at least 500 megs of space available on your device, like after you offline all of those folders, right? We've received some complaints from people saying, wait, why are you doing that? I know what I'm doing. Stop doing that. It's like, yeah, but not everyone is a power user, so we want to keep that restriction there. Okay. So a couple of months later, I'm very happy. We fixed a couple of bugs. I think we're ready. And I come to my boss like, hey, we're good. Let's QA the hell out of this thing, right? Okay. My boss is like, oh, that's pretty cool. Thanks for all of that work. Oh, by the way, so design came up with and said that we should have a global progress of files and number of files in megabytes that have been downloaded. And that's me. Why? Because why is it so hard? It's one of those things where they say about computer scientists that identifying a tree is fairly easy, but identifying all trees in a park is super hard. Just adding one more restriction or one more functionality to a system is very hard. And so what should it look like? So basically that's the case, right? You are downloading this folder and you say I'm downloading this percentage. That's based on megabytes that are being downloaded. It's a little kind of animation. By the way, this is in my entire Android career, this is what I'm most proud of, rotating an icon. I'm going to put that in my resume. You have no idea how hard it's to rotate an icon in Android. But I just noticed that it's going backwards, so I'll fix that when I come back. But basically, that's the idea. Now, why is it so hard? Why is global progress so hard? Well, there's no way to show progress unless you have all of the metadata, right? Because you're saying the folder is this size. So if you don't know what's the size of the folder, you cannot show progress. So a couple of things to consider, right? What happens when you offline a new folder in the middle of a download, right? So you're syncing, and then you mark another folder available offline. Then remember our previous code, you're basically going through the list. And if you are downloading a huge folder, you're not going to notice, right? But you need to update the global progress because now there's a new folder. Do you update both metadata and download files in parallel? What happens when the user unmarks a folder as available offline, right? You need to remove that from the global progress. So as I said, it's a very small constraint, very small feature, but that breaks things. Yeah. Okay. So I sent that for QA, right? And the first thing that they say, these are actual bugs, the little cats. If I mark a folder as offline while another folder is downloading, nothing appears to happen, right? This is QA. It's okay, so what's happening? Order matters. So the first thing that you want to do is download all of the metadata, right? Because that's what allows you to show global progress. And it's kind of intuition that the time to sync the metadata is going to take way less than the time to sync the actual files. So metadata syncing should be relatively cheap compared to downloading actual files. Okay, so I don't feel if I could ask how many people have used a priority queue in their lives. I'm not going to ask that, but it's very computer scientist-ish. It's pretty cool. Metadata retrieval should always happen before file downloading, right? So that's kind of what a priority queue should do. Metadata jobs metadata syncing should happen before download syncing. That's kind of makes sense, right? So let's split our download syncing into 3 parts. 1, syncing, which is the metadata syncing. 2, computing, like what has changed and what do I need to download. And number 3, actually doing the download. And as I said, download can take a lot of time. So if you're downloading 10,000 files, then you want to make that job interruptible. Because the first thing that you want to do is sync the metadata. So if you're downloading a file, then interrupt, and then download the metadata for another folder, and then keep going. So that's an architectural change right there, right? Okay. So okay, let's try again. So now we have an offline file manager. We extract out this functionality, right? Now we have an offline queue, which is a priority queue. Now we have like different classes for the different jobs. The metadata, sync job, compute job, download job. And it's like, as you can see, like it also helped, right? Because it decoupled the offline files manager from the metadata manager. Now, the only dependencies are from the actual jobs, not from the entire offline files manager. So like it was good, right? It was like a nice decoupled design. So that's a little bit better, yeah. And then I send for QA again, and this is what happens. So download stops when I connect to Wi-Fi. It's interesting. Why that happens? Well, in Android, when you move between networks, even if you're like upgrading, like going from cellular network to a wireless network, there's going to be like a brief moment where the connection is interrupted. So if you're downloading a file or you're like performing like an operation over network, it's going to fail. So an ongoing download will be canceled. And now this is way more common because you're downloading 10,000 files. So the likelihood of you running into this is, it's way more likely. OK, so let's implement retry. Well, we already have a shiny priority queue, right? So the only thing that we need to do is like, let's push the failed job back to the queue and keep going, right? So you have your 10,000 jobs that you're executing, like just like, sure, yeah, whatever, it failed. Just push it back to the queue, and let's try. If I get more than 3 consecutive failures, then we say like, OK, we actually are out of network. So let's just fail the entire synchronization. So this was like super easy, right? Like with the previous, like the original architecture would have been very, very hard. But with like the new architecture, it's very easy because it's just another job. So you just like push it back to the queue. And then, OK, crash loop when trying to download a file larger than 2 gigs, right? So basically, the user is trying to download a file larger than 2 gigs. They start the app, it crashes. And there was a crash loop. There's no way to get out of it because it's a crash loop. I don't know. Does anyone have any idea of like? I'll give you 10 seconds. Does anyone have an idea what's happening here? Yeah, basically, and the buffer is not long enough. So that's what's happening. So you'll live and learn. So in Android, less than Marshmallow, this is the Apache library, IO library. Copy file fails for files larger than 2 gigs. So we would crash. So you need to use IO tools copy large, just in case you ever need to copy a file that is larger than 2 gigs. Probably not, but you know something more. OK, next, after a couple days, I cannot preview offline files. And I'm also going to give you like 20 seconds. Like you're the engineer, you're working on this. Actually, we've already shipped the feature. And there's people in production, like real users, telling us like they cannot preview offline files after a couple days. What do you think is going on? I'll give you 20 seconds. Okay. Any ideas of what might be happening? What do you think is happening? No. It took us a while to debug, for like a day or 2. So as I said before, we were using our assets cache, right? And we were saying explicitly, do not evict if this is an offline file. And we were doing the same thing for offline folders. We were basically saying, if this file is the parent of an offline folder, then do not evict. So basically, we were protecting the entire like offline files from eviction. Now it was very interesting because the user could not preview the offline file, but they could export the offline file. So like if they have like a Photoshop PDF file, they couldn't preview it, but they were able to open it in like Adobe or like in Chrome, whatever. So it was very interesting. So this is what happens. Then again, if you guys have to deal a lot with storage, which we do, there's two different methods for getting a directory for storage in Android. One is get cache there. The other one is get there. Get cache there. All of the storage there is evictable by Android. So that means that if there's memory storage pressure, then Android can evict the content, right, of that directory. Get there, that doesn't happen unless you actually go to settings of the app and clear the app data. So why is this happening now? So before we were okay because our cache was very, very small, right? We only have like a couple files. But now when we put like all 1,000 files there, well, Android wasn't happy about that, right? So it was like, okay, wait. You're putting too much into your cache. I'm just going ahead and delete it. So that's what was happening. So yes. So what do we do? So basically, we need two different stores for our assets, for previews and thumbnails. For offline files, then you need to use internal store.getThere. And for any other assets, you use the usual cache there, right? Okay, so this is the actual final architecture of a little bit simplified of the offline files. This remains the same, but now the assets cache is going to be divided in two. The actual cache, and the other one is the persistent store for thumbnails and stuff. Yeah. Okay. So just wrapping it up, what we learned. One is you want your architecture to be flexible enough to account for later changes. I mean, you could argue that we should have been prepared to. By the way, the release date didn't change. So they just came up with this new functionality and feature. And it's like, okay, you need to do this, but the release date hasn't changed. And you can argue that as engineers, we should have foreseen that this could have happened. It's debatable, right? Like whether you want to pre-optimize and make everything beautiful from the get-go. But in general, you want to keep the architecture flexible enough. Number two, adding test coverage. So we had to change everything, right? So you want to make sure that you have enough testing. Two, changes need to be staged. So going from non-delta to delta, which means download all of the metadata to download only partial changes. You don't want to expose all of your users to that breaking change, right? Because basically you could be breaking synchronization for all of the folders, and a Dropbox would be very, very, very bad. So yeah, some sort of staging mechanism. What we could have done differently, design lockdown. I think this is hard, right? But basically, don't tell me to implement something 2 months before launch. And two, don't make assumptions about the underlying working of a system. You could argue that this was my fault, right? I assumed that the assets cache was doing its job. It was protecting offline files, but in reality, it wasn't. So the assets cache wasn't really working as it should have been. So yeah, make sure that you test those assumptions. That's pretty much it. I hope I got this right. Yeah, I got that right. Yes? Okay, perfect. Good. Yeah, if you have any questions about this, or you want to just talk about software architecture, I'm going to be around. And arigatou gozaimasu. Yes? Okay. Thank you.
Actually, we have an office hours.